So let's talk about polynomial function value, or basically the value of a polynomial function. So it's easy. All you need to do is substitution. Done. That's it. It's actually easy. No problem. Just substitution. But in this case, I have to introduce you two methods of substitution. One is the way how we manually substitute, and the second method is synthetic substitution, which is a perfect prerequisite or perfect lesson before you proceed to synthetic division topic. Okay? So let's proceed here. If we have f of x is equal to x squared minus 1, g of x is equal to x cubed minus 2x squared plus x plus 1, and h of x is equal to x raised to 4 plus x squared, find f of 2, g of 4, and h of 3. So how will you find your f of 2? So to give you a short information, let me give you the standard notation of your function. The standard notation of your function looks like this one. Okay. You have a letter of f. Okay. And this letter, beside of your parentheses, it represents your given function. Okay. So here, your f here is 4, x squared minus 1. Your g here is 4, x cubed minus 2x squared plus x plus 1. Your h here is 4, x raised to 4 plus x squared. Meaning, the letters basically tells you the representation of each function. That's what makes them unique. Okay? Then here, the letter inside of your parenthesis, that is your input. Okay? So whatever what's inside in your parenthesis, whether if it is a number, expression, or a function, or whatsoever, as long as it is in the parenthesis, that is your input. So here we have f of 2. So your 2 here is your input. So what are you going to do if your input is your 2? Just substitute it to your x. Finish. I'm not kidding. Just substitute it to your x. So I'm going to substitute 2 to your x here. So you have f of 2 is equal to 2 squared minus 1. So your 2 squared is 4. Then subtract it by 1, we will have 3. That's it. No more things. That's it. Okay? Now let's have g of 4. So how to get g of 4? So since your input is your 4, you're going to substitute it to your x's. Okay? So we will have g of 4 is equal to 4 cubed minus 2 times 4 squared plus 4 plus 1. So we will have 64. Your 4 cubed, by the way, 64. Minus 2 times your 4 squared is 16 plus 4 plus 1. So let's just simplify. 2 times 16 is 32. Okay, then plus 4 plus 1. So in here, 64 minus 32 plus 4 plus 1 will give you an exact answer of 37. See, it's easy. Now, lastly, we have h of 3. Okay, so since your input is 3, you're going to substitute it to your x. So these are your x. So we will have h of 3 is equal to 3 raised to 4 plus 3 squared. So your 3 raised to 4 is 81, plus 3 squared is your 9. So 81 plus 9 is 90. See, that's it. It's easy. Just substitute. All right, that's it. Now let's proceed to the second method. The second method is what we call as your synthetic substitution. But guys, remember this answer, huh? I'm just gonna your f of 2 is your 3. Your g of 4 is your 4. Your h is 90. All right. Now let me erase this one. Okay, because and I do believe that this method will help you in understanding synthetic division, which is another topic we're going to discuss. Okay, so let me erase this one. So yeah, let me use different color. Okay, so let's talk about synthetic substitution. Yeah, correct. Synthetic substitution. Okay, there you go. That's it. Synthetic substitution. Okay. So in your synthetic substitution, there are things that you need to know. Okay. Or sorry, things that you need to be aware of before you're going to synthetic substitution. First things first is to take a look the arrangement of your polynomial. Basically, the arrangement of the terms in your polynomial. Okay? So, in your arrangement, make sure that it is in from highest exponent until the lowest exponent. Okay? So that's one thing you need to know. Okay? Which is the proper arrangement. Okay? Which is, once again, from highest exponent. Okay? Highest exponent until the lowest exponent. Okay? From HE to LE. From highest exponent to lowest exponent. Now, let's proceed to the second thing that you need to be aware of. Now that I've already now that I've already explained to you about proper arrangement, make sure that they are in complete terms. How would you know if they are complete terms? Okay. So for example, I have x plus 1. Look at the exponent. What is the exponent of your 1? That is 0, right? What is the exponent of your constant? It is always, sorry, wait, that's the wrong way to say it. Right? We have the exponent of 1. And since here we have your 1, therefore the exponent of your x here is 0. Okay? So now let's take a look. We're going from 1 to 0. Now, what if I have the highest exponent of 2? So x squared minus 2x plus 1. So again, this is just an example. So we have 2 here. We have your exponent of 1, and the exponent of x here is 0. So from 2 to 1, from 1 to 0. You see? You see the pattern? 1, 2, 1, 0. Now lastly, what if I have x cubed? Okay, so x cubed minus 2x squared plus x plus 1. Again, for example, okay, so we have 3 going to 2, and from 2 going to 1, and from 1 going to 0. So what did you observe? We can see that the pattern of the exponents in both are decreasing by 1. Okay? They are decreasing by 1. So if your highest exponent is 1, then make sure it reaches from 0. It reaches to 0. If your highest exponent is 2, then make sure it slowly reaches to 0 by decreasing it by 1. So we have 2, 1, and 0. That's it. Now, lastly, if your exponent is 3, then the same pattern. Make sure that the exponent of 3, it reaches until 0 by decreasing the exponent by 1. So from 3 to 2, from 2 to 1, from 1 to 0. Okay? Now, let me give you one more example. What if I have x raised to 5? Okay? Then we have what do you call this one? All right, let's just say I have x raised to 5. So what is the proper way on how would you decrease it? So if you have x raised to 5, then the next term should be what? it has the exponent of 4. Okay? Then exponent of 3, then exponent of 2, then exponent of 1 until a constant that it reaches to 0. You guys get what I mean? Basically, make sure that the exponents given are decreasing slowly by 1 until they reach 0. Okay? So, let's take a look at this one. We have x squared minus 1, right? We have this one, x squared minus 1. So take a look at the exponent. We have 2 to 0. So you see, this one is incomplete. Why? Just as I mentioned earlier, the exponent, again, should be from highest to lowest, which is correct. But make sure that the 2, which is your highest exponent, reaches to 0 slowly by decreasing the exponent by 1. However, it reaches 2 to 0. So where is your 1 here? So this is not complete. So you're going to make this as x squared plus 0x raised to 1 minus 1 raised to 0. Do you guys understand what I mean? If there is something missing here, you're going to put 0 times x. Then what would be the exponent will be if it's missing? So let's try this one. X cubed minus x. So obviously, if we have 3 here, your highest exponent of 3 should reach until 0. And again, the exponent should be slowly decreasing by 1. However, we have 3 to 1. So this is incomplete. So we should have x cubed plus 0x squared plus, minus x raised to 1 plus 0. Okay, which is your constant here. So we have 3 going to 2, 2 going to 1, and 1 going to 0. That's how you do it. Okay? So if it's incomplete, you have to complete them by doing this. Okay? That's it. All right? So after you complete the terms, the last step would be just copy the coefficients. Okay? Last step, I'm sorry. The last thing you need to aware of is their coefficients. Okay? When I say coefficients, basically the constants. Okay? The numbers, basically. Okay? So let's try to give an example. We have x squared minus 1, right? So let me move it right here. Okay? Let me move it here. Move it here a bit. Okay. Now that we have x squared minus 1, now take a look. First and foremost, are they in proper arrangement from highest exponent to lowest exponent? So since the exponent of x here is 2, and then the exponent of your x here is 0, then it is correct. Okay, proper arrangement? Okay, good. Next, are the terms complete? The answer is no. Okay, because there is no exponent of 1 here. So therefore, you're going to rewrite it at this way. X squared plus 0x raised to 1 minus 1. So from 2 to 1, from 1 to 0. So you see, it is slowly decreasing by 1, the exponent itself, right? So now that it is already complete, now we're done. Lastly is the coefficients. Coefficients are the constants. So copy them. So we have the coefficient of x squared, which is your 1, the coefficient of 0x, 0, and here, just a constant, -1. That's it. So what's next after you, what do you call this one? After you copy them, now you're going to rewrite it like this. Okay. It's like letter L, but like this format. Then write our input is 2. So you're going to put it here. Okay. So that's it. Now, how would you get your answer? So first, bring down your 1, the first number. Okay? Then find the missing terms. Okay? Then after we find the missing terms, we're going to add them. So let's start with this one. How can we find this? This one. So multiply 2 by 1. So 2 times 1 is 2. So we will put 2 here. So 0 plus 2, we will have 2. That's it. Now, how to find the term on the last column? It's simple. Multiply 2 by 2. So 2 times 2, we will have 4. So 4 minus 1, we will have 3. So this is your answer. That's how you do it, basically. Okay? That's how you do it. Now let's try your second problem. Okay? So we have g of x, right? Your g of x is we have x cubed minus 2x squared plus x plus 1. So let's take a look. Are they in proper arrangement? So from 3 going to the lowest exponent of 0. So yes. Next, are they complete? So we have 3 going to 2, 2 going to 1, and 1 going to 0. So since it's 3 to 0, and the exponents are slowly decreasing by 1, therefore they are complete. Okay, they are complete. Now, copy the coefficients. So we have 1, negative 2, 1, and 1. Then we're going to rewrite just like this. Now, copy the, sorry. It's 4, sorry. Now, copy the input here. So we will have 4. So let's bring down the first number, 1. So let's find the missing value here to your second column. So you're going to multiply by 4. Multiply 1 by 4. So 4 times 1 is 4. So negative 2 plus 4, we will have 2. Now let's get your missing term here. So by getting the missing term here, multiply 4 by 2. So 4 times 2 is 8. That's it. So 1 plus 8 is 9. And now lastly, here, we need to find the missing value at the last column. So to find your missing value, multiply 4 by 9. So 4 times 9 is 36. So 36 plus 1, we will have 37. So this is your final answer. See, that's how you do synthetic substitution. Now let's go to your last, what do you call this one? The last problem. Let's get h of 3. So your h of x is x plus 4 plus x squared. Now let's take a look at the things that you need to be aware of. First is your proper arrangement. Is it from highest exponent to lowest exponent? So we have 4 going to 2. So yes, it is in proper arrangement. So check. Next, is it complete? No, it isn't complete. Because if your highest exponent is 4, therefore it should reach until 0. So as 4 reaches to 0, the exponent is decreasing by 1. So there is missing here. So what we're going to do is x raised to 4 plus 0 times x cubed plus x squared plus 0 times x plus 1. So let's count now the exponents. So from 4 going to 3, from 3 going to 2, from 2 going to 1, and from 1 going to 0. So we can now conclude that it is in complete terms. So that's it. Okay. Now what we're going to do is to copy the coefficients. Okay, copy the coefficients. So we will have 1, 0, 1, 0, and 1. Now let's get the answer for this one. So copy again the inputs in here. So we will have 3. So here, bring down the first term. Okay. First number. So 3 times 1, we will have 3. Okay. Now, 0 plus 3, we will have 3. Now, multiply 3 by 3, so we will have 9. So 1 plus 9, we will have 10. And multiply 3 by 10, we will have 30. So 30 plus 0, we will have 30. And now, since we are at the last column and we're going to find the missing value, we're going to do the same thing. 3 times 30. So we're going to have, wait a minute. There's something missing here. Oh, wait. Sorry. I'm actually wrong. This is supposed to be 0. Hold on, guys. This is supposed to be 0. Wait. Okay, this is supposed to be 0. Forgive me. Okay. Remember that we have x raised to 4 and x squared, right? So take a look. X raised to 4, going to 3, going to 2, then going to 1, right? And then, since you have no constants, okay, you have no constant here, put 0. Okay, I'm sorry. I'm actually wrong. Okay. So once again, if there's a missing constant term, put 0. Okay, I'm sorry. I'm actually wrong. So going back, so this is 0 here. So yeah, copy the coefficient of 0. Okay, so that's it. So yeah, going back. So yeah, 30 times 30, we will have 90. So 90 plus 0, we will have, we will have 90. So that is your final answer. Okay, so that's it. That's how you basically do synthetic substitution. Okay, so yeah, that's how you do it. Okay, so there's also one more thing that I would like to add. What if we are not in a function? Like for example, x cubed minus x. And then our x is equal to 1. For example, okay, how are you going to do this one? Like, find the value for this polynomial expression if your x is equal to 1. Just substitute. It's easy. Okay? So just substitute 1 here and here. We will have 1 raised to 3 minus 1. So the cube of 1 is still 1 minus 1. So 1 minus 1 is 0. That's it. But if you want to use synthetic substitution, it's easy. First, take a look again if the arrangement of the terms are from highest exponent to lowest exponent. So since this is from highest exponent to lowest exponent, then that's good. Okay na. Okay, we're already good to proceed to the next thing. The next thing is it incomplete? The answer is no. Because since um the highest exponent of the highest exponent here is 3, then we need to complete this one by x cubed plus 0x squared minus x plus 0. So you see, the missing here is your x squared and your constant. Okay? So we have 3 going to 2, 2 going to 1, and from 1 going to 0. So that's it. That's how you basically do it. So after that, copy the coefficients. So we have 1, 0, -1, and 0. So after that, copy your value of x here. So we have 1. So bring down the first term. Okay, get the missing term here. So 1 times 1 is 1. So 0 plus 1 is 1. Now, let's get the missing term here again. 1 times 1, we will have 1. So 1 minus 1, we will have 0. So let's get the missing term here at the last column. 1 times 0, we will have 0. So answer is still 0. 0 plus 0 is 0. Therefore, that is your answer. Okay? So that's it, guys. That's how you basically find the value of your polynomial function. Okay? So yeah, I hope you have learned something here in this video. And I'm sorry if the way how I explain for synthetic substitution is quite complicated. Okay, I would like to apologize about that. Okay, as long as there's like a, what do you call this one? There's like a pattern, the one you just observe here. Like for example, right, you have your 3 and you have your 1 here. So make sure that they are complete. Make sure they are 3, 2, 1, until 0. So you see, 2 is missing and the constant here is missing as well. See? So we're going to put 0 times x squared and just 0. Okay? So the same thing as well. For example, if we have x raised to 5 minus x squared. So you see, make sure that if we have 5 here, then we shall have a pattern of 5, 4, 3, 2, 1, 0. So there's no 4, 3, 1, and 0. So we will have x raised to 5 plus 0 times x raised to 4 plus 0 times x cubed minus x squared plus 0x, and for your constant, 0. That's how you basically write it. Okay? I already simplified for you so that you can understand. Okay? So that's the result basically. And I hope you have learned something.